Hello everyone and welcome to Power Playground. This is your host Michael, and today I'm going to be showing you all how to basically speed up your 3D prints. I'm going to be doing this in Simplify 3D, but you can do this in about any slicer of your choice. Usually you'll have settings in your slicer that are very similar to Simplify 3D. So first off, let's go ahead and go over to our view over here. Now this right here is just a set of models. These are some modem brackets I've designed. Now typically with our speed settings, usually the speed, the XY axis movement speed is around like 4,000 millimeters a minute. And now Simplify 3D is a bit odd. Now we can divide that by 60 and that'll be about 66 millimeters a second. That's a typical speed of most 3D printers. That'll be at least, if not printing at, moving at. Maybe a little bit higher, like maybe closer to 100 or so. Now let's go ahead and see how long that will take to print real quick. Let's go ahead and hit prepare to print. And right now we're at 6 hours and 54 minutes. Now the estimation on Simplify 3D can be, it isn't always accurate, but let's go ahead and up that to about 10,000. So if we divide that by 60, we'll get our millimeters a second. Now that's roughly 166 millimeters a second. That's a pretty good bump right there. So let's go ahead and see how that changes our time frame. Okay, so it doesn't change it by much, but depending on the print, this one's pretty efficient when it comes to moving along paths. So some prints are a little more substantial when it comes to changes like this. Let me go ahead and try to fine run real quick. So unfortunately, I wasn't really able to bump up the estimated time in Simplify 3D. I don't think it accounts for that. It's kind of wonky at times, but you can take my word for it. Of course, any of these red lines, these travel moves, are going to be greatly, they're just going to be a lot faster. Of course, we're essentially doubling that speed. So that'll shave off a bit of time in the prints. Now, one thing I do want to say is you want to be careful when increasing this. You'll want to basically test to see what your max speed is, because if you go, for instance, I tried 18,000 millimeters a minute, which let's see here on the good old calculator, that's going to be at 300 millimeters a second. That right there was way too fast for any of my printers. I'll go ahead and pop a picture up here right over the video. And yeah, as you can see, at a certain point, this printer skipped steps and it caused the print itself to skew off a fair bit, which pretty much ruined the print. So you want to be able to avoid that. Right now I'm going about 10,000. I might try to bump up to like 11,000 or 12,000 just to get the max amount of speed possible. But for now, 10,000 will be fine. Now, another thing people will tend to do is they'll bump up their default printing speed. I've actually tried doing this quite a bit, like setting it to like 4,000 millimeters a minute. So that's about 66 millimeters a second, which that will work in a lot of cases. Some prints will be fine with it. Some more detailed prints will not be too receptive and will have a lot of like issues with all sorts of different like overhangs and very intricate areas that require a bit of finessing. So I don't always recommend that, especially with materials like PETG. Those usually tend to go slow. I usually go around 3,200 to 3,400 millimeters a second. Sometimes 3,600. So usually I recommend leaving that alone. That's going to ultimately increasing the actual printing speed is going to sacrifice print quality. Now, another thing to take into account is changing your layer height. With a lot of detailed prints, I go with 0.2 millimeter. It's perfectly fine. I never really go 0.1 millimeter unless if I'm just trying to create something super detailed, which a lot of the prints I do really don't call for that and don't require it. So I try to design my 3D models around the 0.2 millimeter layer height so they don't have any issues with overhangs or anything or any sort of intricate details. But if I want to go a little less detail, I will sometimes go 0.25 or 0.3. So this is at 0.2. This will definitely affect this build time up here. So right now we're at 7 hours and 7 minutes. And of course, like I said, let's see what this slight bump will do. So we'll try 3,800 since this is an ABS print, and that's usually like the highest amount of speed I'll go. So that's already like an hour bumped off right there. So 6 hours 4. Let's do 0.25. Now this model right here, I normally wouldn't do it anything above 0.2 because that's what it's designed for. Some models can get away with that, like some of these higher details. Like overhangs don't typically cope well with higher layer heights, so you want to keep that in mind, unless if you are going the correct speed and what have you, which of course that's just a bit of tuning. So right now we're a little over an hour and like 20 or so knocked off, so that's pretty decent. And then of course if we go to 3mm, that will go ahead and go to 4 hours and 10 minutes. So little over 2 hours knocked off from our original 0.2mm layer height. Not too bad at all. Now another thing to factor in is whenever you increase the layer heights, you are decreasing the amount of shear strength between layers. So your layers will more than likely shear off at like 0.3mm than they would at 2. So if you have like a structural model, it's usually best to do 0.2. Unless if you test it out, make sure that the model itself can stand to be printed in 0.3. Sometimes you can get away with it, but a lot of times I just resort to 0.2 for that safety factor. Other things to keep in mind are keeping your top solid and bottom solid layers low. I like to keep 3 in the top just to make sure there's no gaps or any holes where especially if you're printing out a lower infill, that right there will definitely have some effect there. And then of course bottom layers, only really do 2 of the solid bottom layers because that's more than enough. And then outline and perimeter shells, I usually keep that around 2 or 3, but 2 is typically fine for most cases. And then another thing to keep in mind is setting your infill. Very rarely I'll print anything above like 35%. If I need to print above 35%, I do like a full infill, like 100% infill. And I try to do that with Simplify's 3D's processes, and I try to do that where it needs it most and not throughout the entire print, because that is extreme. A, it wastes a lot of filament, and B, it's going to really slow things down quite a bit. So for instance, something that's not as structural, maybe the areas that need infill don't really need a whole lot of inner structure. It's not going to come up to a lot of force or what have you. You can get away. I usually go usually 15 to 10% is my lowest. Just depends on the size of the print. If it's a larger print, you can get away with this like a really thin infill, like a 10% or so. But of course, even changing this from a 35 to 25% infill, let's see here, what were we at? Okay, so right now, 4 hours and 50 minutes for a 25%, and then 5 hours and 2 minutes. Setting your infill low will decrease your print time and up speeds or the speed of how fast your thing will be printed. But of course, there are a bunch of other factors as well. You can limit the amount of supports that you need or go without any supports. Use rafts very sparingly because, of course, that's more filament wasted, but that's also more time wasted because typically some of those layers are pretty close to solid infill. So you do not want to use those if you don't need them. Another thing I want to talk about is temperatures. I never really mess with the extruder temperatures unless if I'm changing filaments or changing a brand of filament that may be a little bit different from other brands of filament that I normally use. But that won't really net you any benefit to adjust that to save time, obviously, because you don't want jams or anything, and that'll cost you more time ultimately. But changing your bed speed, lowering it for smaller prints, and then raising it for larger prints if needed. Now, this is basically the maximum configuration here. I have a tapering off configuration because I've noticed whenever I keep it at a high temperature, especially with ABS, the bottoms tend to warp, so they kind of curl in a little bit. So usually after like the 6th layer or so, I'll let it lower. I'll just want that high temperature for the initial tack just to prevent ABS or PETG from peeling up off of my PEI sheet bed. So 110 is usually the highest I'll go, and then I'll bump down to 105. Now for medium prints, so anything that's like below like 4 hours or like between like an hour to like 4 hours, I'll go like 105 and then change it to like 100 or so. That'll be fine. And usually if it's like a really short print, I may set the bed to like 100 degrees, and I probably won't back down from that any less, just because that's usually the minimum you want to set the bed temps for ABS at least. PTG, I usually keep it at about like 80 and then 75, something to that nature. But I'll go ahead and double check my settings here. Yeah, about 80, 75. I don't really mess with that too much, just because that's works and it doesn't take a lot of time for my printers to get up to 80 degrees. Now, another thing going back to the speeds is changing these underspeeds values. I have it set to outline to 60%, solid infill underspeed to 85%, and solid structure underspeed to 80%. And that typically nets me pretty decent results with print quality. But of course, it may vary based on your printer or your hot end. That's going to be pretty much it for this particular video. I just wanted to cover the slicer-based improvements to kick up your print speed. In a later video, I'll probably go ahead and go over the hardware improvements you can do. For now, we're just going to focus on software and keep it light. And I just want to thank you all for watching. If you liked this video, go ahead and hit that like button, consider subscribing, and have a great day.